Hello, bonjour, it's Laura here. So in this video, we're going to talk about the relationship between temperature and volume. And the law that we're going to use is Charles' law. So in Charles' law, volume and temperature are directly proportional. So when one goes up, the other goes up. So if you look at this picture here, we've got a bunch of gas molecules or particles, and this flame here is indicating that the temperature is increasing. So if the temperature increases, remember that increases the kinetic energy. So that means that the particles are moving faster. So if they're moving faster, faster than before, they're going to hit the walls of this container more often and harder. So that would increase the pressure, but this contraption here keeps the pressure constant. So what's going to happen is this thing that controls the volume is going to increase. It's going to get bigger. It's going to move up to give the gas the volume that it needs to move around. Okay, so that means that the temperature here is increasing and the volume is increasing in this picture, because this kind of piston thing moves up and down to keep the temperature or the pressure constant. So I'll write that here, keeps pressure constant. And we've got a really good video that Tyler DeWitt does actually that explains how this thing works. So watch that video if you don't understand how that is keeping the pressure constant there. So this is Charles' law. It says that the volume 1 and the temperature 1 are directly proportional to the volume 2 and the temperature 2. So V1 divided by T1 equals V2 divided by T2. And in this, the pressure and the amount are constant. Okay, so the pressure and the amount are constant, so the number of molecules in there are the same, and this contraption is keeping the pressure constant in this picture. So a really important thing about this is the temperature has to be in Kelvin. Okay, so that means if we're given a temperature in Celsius, we need to add 273 to that. So we can graph this relationship. So here we've got temperature on this axis, and then we'll have volume on this axis. Now if we have a lower temperature here, the volume is going to be, well, the volume will be whatever it is, but say the volume is here. Now if the temperature increases, the volume is going to increase. So this would be what the graph looks like. As the temperature increases, so say the temperature went to here, the volume started here, it would increase to here. So that's what the graph would look like. It's opposite of the Boyle's law that we saw. So this is a direct relationship. So remember we said Boyle's law was inverse. This one is called direct. So if one goes up, the other goes up. So can we fill this statement in? When the temperature of a gas increases, its volume should increase, because if one goes up, the other goes up. Okay, so that is Charles' law in a nutshell. Now, the really important part of Charles' law, as I mentioned, is you've got to make sure that your temperature is in Kelvin. So to convert from Celsius to Kelvin, you just take the Celsius and add 273 to it. So this shows us the relationship between Celsius and Kelvin, and also Fahrenheit if you're from the States. But 0 degrees, where the temperature that water freezes in Celsius here, is 273 in Kelvin. Okay? Now there's something called absolute zero, and that is if somebody talks about absolute zero, that is 0 degrees Kelvin. It's the slowest or the lowest temperature that you could have, and it is actually where particles stop moving. So remember, we say that kinetic movement is related to temperature. That's why we say that. So there's no movement here at absolute zero. It would be like a vacuum where there's no particles in it. There's particles, but they're not moving. So gas particles wouldn't be moving. And then as you go up in Kelvin temperature, the kinetic movement increases. Now it's interesting that Kelvin and Celsius go up in the same degrees. So like going from 0 degrees Celsius to 1 degree Celsius, that would be the same amount of heat going from 273 degrees Kelvin to 274 degrees Kelvin. It's the same amount of heat would be applied there. So the increments are the same. And so 0 degrees Kelvin is actually related, is negative 273 degrees Celsius. Okay, so that's the relationship between Celsius and Kelvin, and just always remember that you need your temperatures to be in Kelvin when you're dealing with gas law calculations. And as we said before, this is our relationship. So we can rearrange the Charles law just as we could with the Boyle's law, and really you can rearrange pretty much any formula that you run into. But say we were trying to figure out the volume 1. So we start out with V1 equals T1, or V1 divided by T1 equals V2 divided by T2. So to do this, you can cross multiply first of all. So I multiply the T1 and the V1 and the V1 and the T2. So T1 times V2 equals T2 times V1. Then I'm trying to find V1. So to do that, I'll divide by T2 because that's the opposite of multiplying. So divide by T2 on both sides. Okay. And then that gives me V1 equals T1 times V2 divided by T2. Okay, so in this example of rearranging, I'm doing cross multiplying in the middle step. You can do it a little bit faster. So say I wanted to find T2, for example. You can use cross multiplying, but kind of do a shortcut in your head. So when I'm doing this, this is what I do. So if I'm trying to find T2, I'm going to multiply the diagonal. So T1 times V2, and then divide by the leftover variable. So multiply the ones that are the variables that are diagonal, and then divide by the leftover one. So that gives you T1 times V2 divided by V1. Okay, say I was trying to find V2, I would do the same thing. So I'll just write out the formula again here. And I just want to change this equals just to an arrow. So we're saying we're just finding V2 here. Okay, so if I want to find V2, I'll multiply by the variables that are diagonal and then divide by the leftover one. Okay, so that's going to give me V1 times T2 divided by T1. Okay, now you can do the same thing with T1. We haven't figured that one out yet. So T1, I'll use our equation up here, that's going to be V1 times T2 divided by the V2 that's left. So V1 times T2 divided by the V2, which is left over. Okay, so it's very easy to rearrange your equation so that you can solve for any of those variables. So let's try a question here. We've got a balloon that's got a volume of 785 milliliters at 21 degrees Celsius. If the temperature drops to 0 degrees Celsius, what's the new volume? So first thing we want to do is fill in our chart of variables and then determine the law. So let's pretend we don't know what law we're dealing with right now, and we'll fill in this information. So we've got a balloon that has a volume of 785 milliliters. So that is the starting volume. 785 milliliters. 785 milliliters to start, and the starting temperature is 21 degrees Celsius. Okay, so hold on a second here. Remember, we can't have a temperature in Celsius, so we need to add 273 to that so that we get a temperature in Kelvin. So that's going to give us 294 Kelvin. Okay, so now if the temperature drops to 0 degrees Celsius, so there's been a change, it drops to 0 degrees Celsius. So we'll change this to Kelvin temperature. So that means 273 degrees Kelvin. Remember, that's the same as 0 degrees. Okay, and then we've got our question. What is the new volume? Okay, so we don't know the volume. Now, we don't have any information about pressure. Okay, so pressure we're not dealing with here. So what law would this be then? Okay, so we know that we're dealing with Charles' law because we're dealing with temperature and volume. And then what is Charles' law? So then Charles' law is volume 1 over temperature 1 equals volume 2 over temperature 2. Okay, so let's make our predictions. We know that Charles' law is direct, right? If one goes up, the other goes up. So what we see here is that temperature starts at 21 and goes down to 0. So that means that temperature has decreased. And so what should we see happen with the volume? We should see that the volume also decreases. Okay, so that's our prediction. Now we want to rearrange our formula to solve for our unknown. And I'm just going to erase my direct there. So we want to figure out V2. So to figure out V2, we're going to multiply V1 times T2 and then divide by T1. So V2 equals V1 times T2 divided by T1. Okay, so now let's substitute our values in and solve for this. So we've got V2 equals, and then our volume 1 is 785 milliliters. We're going to multiply that by the T2. So that is 273 Kelvin. And then we need to divide by T1. So that's 294 Kelvin, right? I'm getting this from here. Okay, so our Kelvin temperatures are going to cancel out. We're going to be left with milliliters, which is what we want. That's the volume. Okay, and when we do this math, you're going to get 729 milliliters. Okay, so the initial volume was 785, and we've gone down to 729. So that is a decrease, and that is what we were predicting. So that matches our prediction there. Okay, so that's an example of solving a Charles law question. Okay, well done, Miigwech.